Here you can see complete signaling of a VoLTE call starting from UE boot up. We can divide this complete signaling into mainly 4 steps. In first step, VoLTE UE attaches itself to the LTE network and establishes a default bearer for internet connection. Here in this set of messages, UE is attaching itself to the network and setting up default bearer for internet connection. Remember, this step is performed by each UE, whether it is VoLTE capable or not. Then in second step, VoLTE UE establishes a default bearer for IMS signaling. We call it IMS default bearer. This set of messages is used to establish an IMS default bearer. After this bearer is established, UE is able to communicate with IMS network via LTE network. Then in third step, VoLTE UE registers itself with IMS and subscribe for registration event with IMS network by exchanging SIP messages. Finally, in step 4, VoLTE UE makes MO VoLTE call by exchanging SIP messages with IMS. During this step, dedicated bearer for voice call data is established in LTE network. Now you can easily imagine that there is so much to discuss in these logs. In this current video, I will cover first and second step. After this video, our major LTE signaling part will be over. In second video, I will cover IMS registration and subscription. In third and last video, I will cover VoLTE MO call. Let's start with this first video, guys. See, I will go through only those UE messages that are important from VoLTE perspective. If you are new to log analysis and want to understand this complete log, I would suggest you to first go through my video on RSC connection setup and then come back to this video. Let's start with log analysis. No need to discuss RSC connection request and RSC connection setup messages, as there is nothing VoLTE specific in these messages. Then comes this RSC connection setup complete message. Here you can see UE is sending this NAS PDU. This NAS PDU is nothing but encoded NAS message, attach request and PDN connectivity request. Let's analyze decoded form of this NAS PDU. Attach request. Here attach type is combined EPS IMSI attach. It means UE wants to attach to both PS and CS domain. Here is PDN connectivity request message piggybacked inside attach request message. UE is sending this PDN connectivity request message to establish a default bearer for internet connection. Here UE is telling whether it supports SRVCC or not. As you can see, this UE supports SRVCC. Here is voice domain preference. It is the most important I that tells whether UE is VoLTE capable or not. Here, voice domain preference for EU train is IMS PS voice preferred and CS voice as secondary. It means VoLTE call is preferred and circuit switched voice call is only a second choice. UE capability information. When UE supports VoLTE, it should support other features that are necessary for a VoLTE call, such as semi-persistent scheduling, TTI bundling, SRVCC, etc. UE tells its capabilities to support these features in UE capability information message in the I feature group indicators. Each bit of this I represents some feature. RRC connection reconfiguration. Using this RRC connection reconfiguration message, network is setting up SRB2 and DRB1 in UE. This is the encoded NAS PDU having NAS message attach accept. EPS bearer identity of this default bearer is 5. DRB identity is 1. Logical channel priority of this DRB is 12. You must be wondering why I am discussing this message even though it is not related to VoLTE. You know, it is necessary to note down parameters of default bearer used for internet so that we can easily understand default bearer for IMS and we can do comparative analysis. Here I am noting down these values. These parameters will be useful when IMS default bearer will be discussed. Attach accept. Here is decoded attach accept message. Basically, this message is reply from network for attach request message sent by UE. Here is activate default EPS bearer context request message. It is a reply from network for PDN connectivity request sent by UE. Let's go inside it. QCI is 9. Here is the APN returned by network. Let me tell you one interesting thing here. UE does not send any APN while sending PDN connectivity request message for establishment of default bearer for internet access. A list of APNs and UE is allowed to use is stored in HSS. Network chooses one of the APNs from this list and shares it with UE in activate default EPS bearer context request message. Here is IPv4 address allocated by PDN gateway to the UE for internet access. Here is something important. This IMS voice over PS session in S1 mode supported tells that this UE is allowed to make a VoLTE call. For setting this I as true, MME checks UE capabilities, network capabilities, and UE subscription data from HSS. If both UE and network are VoLTE capable, and UE is allowed to make a VoLTE call as per its subscription data in HSS, MME will set this I as true. Now UE knows that it is allowed to make a VoLTE call, so it has to register with IMS network. But did you notice till now there is no data path between UE and IMS network? So UE has to make a IMS default bearer so that it can talk to MS network. In order to do so, UE will again send message PDN connectivity request to LT network. Let's analyze this message. PDN type is IPv4 v6. It means this UE can support both IPv4 and IPv6 address types. But let me tell you one thing. As per specifications, it is mandatory for a VoLTE UE to support IPv6. APN name is IMS. Here I want to tell you two things. First thing, name of this APN is same for each mobile and for each network in the world. It is defined by specifications. Even in roaming network, UE will send this APN. So it is kind of universal. Second thing, as we discussed earlier, while setting up default bearer for internet connection, it is non-mandatory to send some APN to the network. If no APN is sent by UE, network will use default APN. But while setting up IMS default bearer, UE has to send this APN to the network. Protocol configuration options. UE uses protocol configuration options to request additional parameters of the destination network to which UE is going to connect. In this case, destination network is IMS. Here each protocol ID has some value. Each value has some special meaning as defined in specifications. Value 1 means PCSCF IPv6 address request. So UE uses this value to request PCSCF address from the network. Value 2 means IMCN subsystem signaling flag. This flag is used by UE to intimate to the network that this default bearer will be used for IMS signaling. Value 3 means DNS server IPv6 address request. Value 12 means PCSCF IPv4 address request. Value 13 means DNS server IPv4 address request. Did you notice length of content of each protocol ID is 0? See, because UE is just requesting these parameters from network, so length is 0. When network will return back these parameters, then this length field will have some value. Just wait for some time, we will come to that thing in a while. RRC connection reconfiguration. Here is RRC connection reconfiguration message in which network is setting up IMS default bearer at UE. Let's analyze this message. Here is encoded NAS PDU having message activate default EPS bearer context request. EPS bearer identity is 6, DRB identity is 2, logical channel priority is 4. Let's now look into decoded NAS PDU and analyze NAS message activate default EPS bearer context request. QCI is 5. This is the IMS APN returned by the network, and this is the IPv6 address allocated to the UE. Now let's come to this important parameter, protocol configuration options. We saw earlier that PCO was used by UE to request few parameters from network. Now we will see what all information network has returned back in PCO. Value of the protocol ID 1 is 5. 5 means contents of this protocol ID will have the parameter selected bearer control mode. Length of the protocol ID 1 contents is 1. Contents of the protocol ID 1 is 2. So selected bearer control mode is 2. Parameter selected bearer control mode is basically used by network to tell UE whether bearer creation and modification can be triggered only by UE, or both UE and network can trigger bearer creation. Value 2 means both UE and network can trigger bearer creation and modification. Value of protocol ID 2 is 1. 1 means contents of this protocol ID will have PCSCF IPv6 address. Length of the protocol ID 2 is 16. Here is IPv6 address of PCSCF. This is encoded IP address. After decoding, it will come out to be this. Value of protocol ID 3 is again 1. So contents of this protocol ID will also represent PCSCF IPv6 address. Here is IPv6 address of PCSCF. This is encoded IP address. After decoding, it will come out to be this. You can easily notice now that network has shared with UE IP addresses of 2 PCSCF. Now you will send activate default EPS bearer context accept to the network, and establishment of IMS default bearer will be completed. One important point, guys, IR 92 says it is highly recommended that the default bearer is used for SIP and XCAP. This reduces the number of EPS bearers used. However, in multimedia operations, another configuration can be used. So it makes sense to use IMS signaling bearer for XCAP as well. Let's do some quick comparison of various parameters of default bearer for internet and default bearer for IMS. You can see logical channel priority of IMS default bearer is much higher than the internet default bearer. This difference in priorities is quite obvious, as IMS default bearer is used for SIP signaling. Next parameter is QCI. QCI means QoS class identifier. Here is QCI table. You can see both QCI 5 and QCI 9 belong to non-GBR services, but QCI 5 has much lower packet delay budget and packet error loss than QCI 9. Last parameter is APN. While sending requests for internet default bearer, normally UE does not send any APN, but while sending requests for IMS default bearer, it is mandatory for any UE to send IMS as APN. Let's first understand why do we need registration and what is the relevance of registration in SIP. Basically, registration is a process in which a SIP client sends its identity and IP address to the SIP proxy, and SIP proxy makes an entry for this client in its database. This entry has IP address of the client and its identity. So whenever there is an incoming message to the SIP proxy takes the identity of the client from the SIP message and then it refers to its database. And from its database, it checks what is the actual IP address of the client. Then SIP proxy forwards this message to the SIP client. So this is the purpose of registration. Let's first have a quick overview of registration process. After that, we will start log analysis. A VoLTE UE triggers registration process by sending registration message to the CSCF. CSCF shares identity of this UE with HSS and gets authentication vector. CSCF picks authentication challenge from this authentication vector and sends this authentication message in 401 unauthorized message. UE verifies this authentication challenge at its end to check whether network is authentic. If network is authentic, UE calculates authentication response and sends a registered message again with authentication response. Network verifies authentication response. If authentication response is valid, UE is considered to be authentic. Then CSCF makes entries for this UE in its database and sends 200 OK message to intimate UE about successful registration. VoLTE UE sends unprotected register message to CSCF to trigger registration process. I'm saying unprotected because this message is sent on default TCP UDP port 5060 that is used for unprotected SIP messages. The very first line of register message has register method and domain name of SIP proxy of this UE. Via header. UE has added via header to tell that this message has traversed UE. You can see UE has added its IP address and default TCP UDP SIP port. Max forwards. Value of maximum forwards is 70. It means this message can traverse at most 70 hops. Every hop reduces this count by 1 before sending this message to the next hop. Purpose of this header is to prevent a message to move in a network for forever in case it gets trapped in some loop. To and from headers. In register message, to and from headers have same URI. This URI is made up of UE's private identity and domain name of its proxy. This is the private identity of the UE and this is the domain name of the CSCF. Let me highlight. Register message is a special case in which both to and from headers have same information. Normally, to and from headers represent destination and source of a message respectively. Invite message is one such example. Call ID. Call ID uniquely identifies a call. Call ID is made up of two parts. First part is random number generated by UE and second part is UE's IP. This is standard way of making call ID as per RFCs. CSEQ. This header has sequence number and the method name. The CSEQ number is incremented for each new request within a dialog. Simply said, it acts as a sequence number within a SIP dialog. Authorization. This header has all the parameters related to authorization. Let me discuss each parameter one by one. Here, UE is telling that digest authentication scheme will be used for authentication. This digest authentication scheme is not something new. It is already used by web browsers for authentication from a long time. All these remaining parameters are needed for digest authentication scheme. Username parameter has UE's private identity. This private identity is used by CSCF and HSS to check whether it is a genuine UE or not, and what all IMS services it can avail. Realm parameter should have domain name of the UE's proxy. Nonce parameter is empty when UE sends register message for the first time. This parameter will have some value when UE will send register message for the second time. I will discuss this parameter at that time. URI parameter also has domain name of the UE's proxy. Response parameter is also empty. UE will send this parameter when it will send register request for the second time. Contact header. Contact header either contains a global SIP URI or a global IP address on which sender of this message can be reached directly. C. Very first SIP message from sending SIP node to receiving SIP node may traverse through many other SIP nodes. But once this first message is received by receiver can directly send response to the sender by using information present in this contact header. Here, UE has mentioned its IP address in contact header. Port is 5060. This is default TCP UDP port used in SIP for non-encrypted signaling traffic. So here UE is saying you can reach me directly at this IP address and at this port. These other parameters are called header field parameters. In SIP.instant contact header field parameter, UE provides its unique ID. This unique ID is called Uniform Resource Name. For VoLTE UE, this unique ID is IMEI of the UE. ICSI means IMS Communication Service Identifier. Basically, it is a feature capability indicator of the UE. If you want to check actual meaning of this field, go to this link and search for the word MMTEL. I will mention this link in the description section of the video. You can check on your own. Basically, here MMTEL means this UE supports multimedia telephony. SMS IP. Using this field, UE is telling that it supports SMS over IP. In other words, this UE supports SMS over IMS. Audio. This is a feature parameter. UE can have multiple feature parameters such as audio, video, text, data, events, etc. Feature parameters are used by callers to tell its preferences to the callee. To see the complete list of feature parameters, you can go to RFC 3841. Here, absence of other feature parameters means this UI wants to have only audio chassis. Access type. This field tells what kind of access technology UI is using. Various values in this field could be WLAN, Ethernet, cellular, etc. Expires. Expired header tells how long this registration will be valid. This time shown here is in seconds. If I do mathematics, this time will come out to be approximately 166 hours. So UI will have to renew its IMS registration after 166 hours. Require. As per the specifications, we must add both require and proxy require headers. TagSec agree indicates that this SIP client supports security agreement mechanisms. Supported. If there are a few extensions to SIP that UI supports, then it can add a supported header and list those extensions in this header. Security client. This header has a list of security mechanisms that a SIP client supports. This header has lots of information, so I have copied it to the notepad for easy analysis. Here you can see UI has sent all 6 possible combinations of security parameters that it supports. IPsec represents the security mechanism. ALG is meant for authentication algorithm. EALG is meant for encryption algorithm. Port C defines the secure client port at UI side. Client port means this port will be used at UI side for outgoing data to the server. Port S defines the secure server port at UI side. Server port means this port will be used at UI side for incoming data from server. SPIC. SPI is concept related to the IP security. This is SPI associated with the client port. SPIS. This is SPI associated with the server port. Port defines the IPsec protocol. Mode. This parameter defines the mode in which IPsec protocol will be used. PXS network info. As the name suggests, this header tells information about the access network of the UI. Here, UI is telling that it is connected to the EU TRAN in TDD mode. Also, UI has mentioned its cell ID here. 401 unauthorized. After getting register message from UI, CSCF will consult HSS by sharing UI's private identity with it. If HSS intimates CSCF that this UI is entitled to use IMS services, then CSCF will request HSS for authentication vector. Authentication vector is a set of parameters used for authentication. CSCF will send RAND and AUTN parameter in combined manner as the nonce parameter in 401 unauthorized message. Let's analyze this message. This time I will skip those headers that we have already discussed. Authenticate. The JAS is the authentication mechanism. Realm parameter will always have domain name of the network. Nonce is the authentication challenge sent by CSCF to the UE. Nonce is made up of RAND and AUTN. Here is the authentication algorithm that has been used for calculating this nonce. Security server. In this header, server has told that which combinations of security parameters server supports. Let me copy these options also in Notepad to do comparison. You can see server has chosen this combination of security parameters from the list sent by UE. Here you can see the way UE didn't register message, server has also shared its client and server ports in this message. Register request. Now UE will calculate AUTN at its end. If this calculated AUTN matches with the AUTN received from the network, UE will assume that network is authentic. Then UE will calculate response parameter and include this response parameter while sending register message again. But before sending the register message again, UE will choose common security mechanism and implement IP security. Remember, after implementing this security, all the communication between UE and CSCF will take place on the ports that were exchanged earlier. It means default TCP/UDP ports will not be used anymore. Once communication between UE and CSCF is secure, UE will send register request again on secure client port, that is port C. Let's compare this second register message with the first register message in Beyond Compare tool and see what all new or changed information UE is sending now. In left tab we have first register message, in right tab we have second register message. VIA. Here in VIA header, UE has changed default SIP, TCP or UDP port to the port S. As the information present in VIA header is used while sending back response to the UE, so port S is used. Let me repeat, port S is used for incoming data from the server and port C is used for outgoing data to the server. Authorization. Here in authorization header, UE is repeating the nonce that was sent by server. Most importantly, UE has included calculated response also in this header. Contact. Default SIP TCP UDP port has been updated in the contact header to port S. Remember, this information present in contact header will be used by CSCF to send SIP messages to UE directly. Security verify. We have already seen this header in 401 unauthorized message from server. Here, UE is including this header again to repeat all the information that server has sent earlier. UE repeats this header to tell server that same UE, not an intruder, is sending register message again. 200 OK. CSCF will compare response sent by UE with XRES. XRES means expected response. If it matches, then CSCF will assume that UE is authentic and will make all the necessary entries for this UE in its database. Finally, CSCF sends 200 OK message to mark successful registration. Note, CSCF sends this message on its secure client port 9950. P associated URI. P associated URI is the most important header in this message. This header contains the list of the UE's public identities for which entries were created during registration process. Actually, for each public identity of the UE, an entry is created in HSS. As this UE has got two public identities, so two entries would have been created in HSS for this UE. Interestingly, till now UE has not sent public identity in any message. It has sent only its private identity, but UE's public identities are already present in HSS. At this point, UE is successfully registered with IMS network. Now next step is to subscribe for registration event. UE sends subscribe message to the CSCF to subscribe for registration event. The subscribe method is used to request current state and the state updates for a particular event. Let's see contents of this message. Most important header in this message is event header. This header denotes the event for which UE is subscribing here. Here, value of this header is registration. 200 OK. CSCF sends 200 OK message to tell UE that subscription was successful. Notify. After successful subscription for registration event, CSCF sends notify message to UE. Notify message is used to tell the current state or any change in the current state of an event for which a SIP client has subscribed. This time, notify message is telling UE the current state of the registration event. This current state is present in notify message in the form of XML document. A XML registration information document begins with the root element tag raginfo. Here you can see two registration sub-elements. First is this and second is this. As we saw at the time of registration, this UE has got two public identities, so two entries would have been created for this UE in HSS, one for each public ID. You can easily notice that first registration sub-element refers to the first public identity, that is CPURI, and second registration sub-element refers to the second public identity, that is mobile number of this UE. Incoming SIP messages at CSCF can have either CPURI or telephone number. In both cases, this request will reach to the same UE. 200 OK. UE will send 200 OK message at the response of the notify message. This message completes the subscription process. An UE triggers a VoLTE call by sending invite message to the target UE. This invite message includes all the parameters of the media session that originating UE wants to have. But remember, at this stage, originating UE does not know the IP address of the terminating UE. So originating UE has to send this invite message to its SIP proxy, that is CSCF. Once this message is received by CSCF, it checks whether the target UE is reachable or not. If it is so, CSCF sends reply to originating UE by sending message 100 trying and forwards this invite message to the terminating UE. Terminating UE needs to reserve network resources for this session at its end before alerting the user. So terminating UE starts working on resource reservation at its end and sends 183 session progress message to the originating UE to tell that it is working on the resource reservation. In this message, terminating UE tells properties of the media it is going to reserve. After getting 183 session progress message, originating UE first sends the provisional acknowledgement to the terminating UE and then starts working on the resource reservation at its end. Once originating UE finishes reserving resources at its end, it sends an update message to terminating UE. Terminating UE returns a 200 OK response for the update message, indicating that all the preconditions for the session have been met. At this point, terminating UE starts alerting user by ringing the mobile. Terminating UE sends 180 ringing message to the originating UE to tell that it has started ringing the mobile. Originating UE sends provisional acknowledgement for this ringing message. Terminating UE sends OK as an acknowledgement for this provisional ACK message. When user at terminating end picks the call, terminating UE sends OK message as an acknowledgement of invite message. Originating UE sends ACK message. This leads to completion of the call. After this, voice call data can be transmitted successfully. Till now we talked about only SIP messages, but one DRB has to be set up at UE side for this voice call data to be transmitted on air interface. Let's talk about creation of that DRB now. PCSCF triggers creation of dedicated EPS bearer by sending AA request message to PCRF. PCRF sends IP CAN session modification to PDN gateway. PDN gateway sends create bearer request to serving gateway. Serving gateway sends create bearer request to MME. MME sends bearer setup request to eNode B. Then eNode B sets up this DRB at UE by sending RRC connection reconfiguration message. This DRB has QCI 1 for voice call data and QCI 2 if it is a video call. I talked about these QCI values in my previous videos also. Let's now jump on to log analysis. See, in my last video I discussed headers of SIP messages in detail. So in this video, I will go through only those headers that are specific to the VoLTE call. Invite. In this message, UE lists its media capabilities in the form of SDP extensions. SDP means Session Description Protocol. SDP does not deliver media itself, but it is used between endpoints for negotiation of media properties. So here you can see originating UE has included all its media capabilities. Trying. There is nothing important to discuss inside this trying message. RRC connection reconfiguration. Here you can see DRB ID is 3. DRB1 is used for LT signaling, DRB2 is used for IMS signaling, and DRB3 is used for data flow of a VoLTE call. This VoLTE call can be audio or video. Here you can see value of QCI is 1. For voice call, value of QCI is 1, and for video call, its value is 2. Session progress message. You can see here in this message, terminating UE has included its media capabilities for negotiation purpose. As I said earlier, update message is sent by originating UE after reserving resources for media. Here, UE has included final set of media parameters. 180 ringing. So at this stage, terminating mobile has started ringing. Terminating UE sends acknowledgement of PREG when user picks the call, and at the same time it sends acknowledgement of invite message. originating UE sends ACK message and it completes the VoLTE call.